Hey guys, so today we are going to do area of regular polygons. And when we mean regular, we're talking about polygons whose sides are all equal and whose angles are all equal as well. So we're talking about, everything's the same, sides, shape, everything. So when you see this thing inscribed in the circle just gives us a basis because any regular shape can be inscribed in a circle and all the vertices will test a circle. And it helps us when we're talking about definitions. And that's what we're going to start with first. So I give us this diagram here. And we know that the center of the polygon is basically like the center of the circle. So we see here we have a hexagon here in black on the screen. And what you see is that the center, right there, dab in the middle, boom, 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 right there where I just tapped, put it in green so we can see it. The center right there is the center also of the whole circle, the red circle you see going around the hexagon. It's the same thing. But when you see here center, that's what we're talking about. So dead center of the polygon. The radius of the polygon is basically like the radius of the circle. So basically it's from the center and it goes to one of the vertices. And it doesn't matter which vertices you go to, whatever. I'm going to erase the green there just because I want to keep it in blue. But it goes from the center, it goes to any of the vertices. So that's when we see, when you hear radius, that's what they're talking about. Now, the new stuff that we haven't seen before is the first one is called the apothem. Right here, the apothem. And that is basically a segment that goes from the center to the midpoint of any of the sides. So right here in purple, as we see here, this is an apothem. And I also drew it up here between the two radius, and you'll see that it cuts that triangle where two radii create a triangle. It cuts that triangle completely in half. So it goes from this. It goes to the dead center. It's a midpoint. So if you really want to think about it, those two segments would be congruent as well. And that's going to help us because it goes straight down, it's also perpendicular, which helps us create right triangles, as you see up here in the top right. So think about, guys, if it's right triangles, trig, Pythagorean theorem, all those things come back into play for us. So you got to remember doing that. So, all right, now we start getting some other things. Central angle of a regular polygon. Well, to find a central angle, the central angle here is the angle between any two radii. That's the central angle. So I just marked it in green up here in the big blue one. We have our blue triangle here up top, boom, boom with the center. And then the central angle is the angle created by the two radii up here. So if you think about that, and the angle, how you find that angle, it's very simple. It's 360, because again, all the way around is 360, divided by the number of sides. So that's what n is. N is equal to the number of sides. If you do not remember that when we started just basic polygons earlier in the semester, again, n always represents number of sides. So in this case, how many sides? So in this case, since this would be this is a hexagon, it has 6 sides, so the central angle will be 360 divided by 6, or 60 degrees. So keep that in mind in how we do things. All right, I know this page is a little blurry, sort of how a copy, but we're going to work with it. In the diagram, A, B, C, D, E is a regular pentagon. So guys, pentagon, 5. Is inscribed in circle F. Find each angle measure. So the first angle to measure to ask for is AFB. So we're going from A to F to B. So we see that AFB is a central angle. So in this case, we're going to do 360 divided by 5, and that's going to give us 72 degrees. So we see that for part A, it's 360 divided by 5. Number of sides, central angle, that angle right there. Then the next thing they ask is for AFG. AFG. So it's asking for basically when we drop the apothem, because that's what FG is, we drop the apothem, what is the angle that's created there? Well, basically it's half of my central angle. So I'm just going to take 72 and divide it by 2, and that's going to give me 36. Now that's going to be important to be able to do that because that helps us with the right triangles there. And then the last thing is have GAF. So the last one here is GAF, which is this angle right here. Well, guys, if we think about it, there's G, there's A, and there's F, and we know that this angle here is 36, and we know that's a right angle. Well, how do we find A? Well, it's basically 90 minus 36. In this case, it would be 54 degrees. Again, right triangle. So if you think of it that way, it makes it a little easier. Or you can do the big triangle and do isosceles triangles and solve that as well. Any of those ways will work, but I prefer doing the right triangle. Works better. All right. So now we're going to jump into the meat of the discussion today. Area of a regular polygon. Now the formula is fairly simple, but figuring out the parts can be tricky sometimes. You have to remember your trig and all that other stuff. You can find the regular area of any regular n-gon, so it doesn't matter, 3 sides, 4 sides, 5 sides, 6 sides, 20 sides, 100 sides. You can find it no matter what, as long as it's regular, by doing this formula. By dividing it into congruent triangles. So basically, guys, we can take what we're looking at and we can just break it up into triangles. And if we find the area of one triangle, we just multiply it by whatever is necessary to do for the whole thing. So the formula we have here is the area of a regular n-gon with side lengths of S, side length of S, is 1/2 the product of the apothem, A, and the perimeter. So you'll hear me use A equals 1/2 AP, but another way of saying P is number of sides times the side length. You guys remember this from doing squares or equilateral triangles or whatever. Find the perimeter of anything regular, it's whatever the side length is times the number of sides. You've been doing this before, but it's not too bad. So I'll use 1/2 AP, but if you want to think about it, N times S. Little a is always the apothem. Big A is for area. So we're going to use this formula going forward. So we're going to start out here, and we're going to do 3 steps, basically how to do this and kind of how I'm breaking it up. All right. So we want to find the area. You're going to need a calculator. If you don't have a calculator, you need one. So pause it right here and get a calculator if you don't have one right now. All right. Find the area of a regular octagon with 15-inch sides and a radius of 19.6 inches. So I'm going to kind of do this a little here. I know that the sides are 15, so I'm going to put 15 on one of the sides. And I'm just doing top right because I'm going to use the bottom here because I like to work on the bottom here for my triangles. And it says that I have a radius of 19.6. So I'm going to put a center, and then I'm going to draw a radius here down this way, and I know this is 19.6. And our steps say, draw a center, radius of the polygon, and apothem. So I drew a radius, and now I'm going to draw my apothem. And my apothem drops straight down and is perpendicular. Now we know that every side is 15, and what I told you before is that the apothem, it cuts the side at a midpoint, so it's congruent on each part. So if each side is 15, that means that each part of this has to be 7.5. So if you look at it, guys, we now have a right triangle, and I'm going to draw it over here to the side, where you have one leg is 7.5, and you have a hypotenuse is 19.6, and the only thing missing is my apothem. Now, we're going to get back to the apothem in a minute because we need that to solve for the area. Now, this one's not actually a very hard problem because we can solve for the apothem. You guys probably already guessed how to do it. But we do need to know certain other things sometimes when we're solving. And the first thing we need to know a lot of times is, what is this angle right here? The angle that's part of the central angle. Now, it's not a central angle. It's half a central angle. So if you remember, to find a central angle, it's 360 divided by n. But if we're doing half of that, it ends up being 180 divided by n, which I put over here. So in this case, that angle is actually 180 divided by 8. And what we see here is that that's going to be 22.5 degrees. Now, for this problem, it's not actually going to help us to know that. It's just a little superfluous info. But in later problems, you need that because if we're going to do trig, you got to have an angle to figure out things. In this case, we already have 2 sides of a right triangle, so it's going to be a little bit easier. All right, so in this case, we need to find the apothem. So we need to find A here. The apothem, right there. So I'm going to use Pythagorean theorem to figure out the apothem. So I'm going to say A squared plus 7.5 squared equals 19.6 squared. All right. And when I do that, that's basically I'm going to rearrange this as a squared equals 19.6 squared minus 7.5 squared. And I'll put these in parentheses so it's easier to read. And when you do that calculation, you're going to get 327.91. That's rounded. And then if I want to find A, I'm going to take the square root of both of those. So I'm going to take the square root of that. So that ends up being 18.11. So there's my apothem right there, 18.11. So I'm going to draw my little arrow up there for that. So now I can actually solve for my area of the whole thing. So in this case, my area is equal to 1/2 the apothem, which is 18.11, times my perimeter. Well, my perimeter, each side is 15, and then I know there's 8 sides, so it's 15 times 8. So in that case, if you think about it, it's 1/2 18.11 times 15 times 8. Well, 15 times 8, that's 120. And so in that case, I'm ending up with 1,086.5, and since we're dealing in inches squared. So I had to find my apothem, and then I used my apothem, and I used my perimeter to solve. I didn't need the radius. The radius actually only helped me solve for the apothem, but I didn't need it for my area formula. So remember what you need and what you don't need. Sometimes you're going to need to find things. Sometimes you may have already gotten it. You don't need to solve for anything else. All right, here's another one. A regular nonagon, so remember nonagon means 9 sides, has a radius of 4 units. So now they're only giving us the radius. They want you to find the perimeter and area of the nonagon. Okay, so because they only gave us the radius here, we got to do a few calculations. All right. So first things first, let's draw what we know. We know a radius of 4. So I'm going to put my center, and I'm going to draw my radius, and I'm labeling it as 4. And then the next thing I need to do is draw my apothem. And I need the apothem. And I really do need this bottom side down here as well. So I'm going to put that as x. And then I know the whole thing here has to be 2 times x. Because I need the whole side so I can get the perimeter. All right? So I need the apothem, I need x. And I got a radius of 4. So remember how I said solve for an angle? Because I now have a right triangle here, but I only have a side. I have nothing else. So I need an angle, or I need a side to figure out the rest of it. Since I don't have any of the other sides, I can figure out the angle right here. This is half the central angle. So I know that angle is 180 divided by 9. So in this case, it's 20 degrees. So I know my angle right here, 20 degrees. So I'm going to redraw this right triangle just over here at the top and say I have a radius of 4, and I know my angle right here is 20 degrees. And I need to find A, and I need to find X. You guessed it, we got trig coming. All right? So let's start with the apothem. Now, if I do it based on my angle 20, I know my X here is opposite, I know my apothem is adjacent, and I know my hypotenuse is 4. So looking for adjacent, given the hypotenuse, yeah, we're going to use cosine. Cosine of 20 equals my apothem, A, over 4. So A is equal to 4 times the cosine of 20. And when we put that in our calculator, we should get that as roughly 3.76. Now I need to find X. All right. So the good thing is I got my apothem. My apothem is 3.76. So I know this part, 3.76. I need to find X so I can find the whole side line. So to find X, right, I'm looking for my opposite, and I know my hypotenuse, so I'm going to use sine. Sine of 20 equals X over 4. X equals 4 times the sine of 20. And that, when we plug it in, gives me roughly 1.37. So I know X here is 1.37. So if I want to find the whole side, remember, I need to double that. So 2 times 1.37, that's going to give me 2.74. So now from there, I can solve for area, I can solve for perimeter, since it asks for both of them. So the first thing I'm going to do is perimeter, because I need perimeter for area. So to find my perimeter, well, perimeter is pretty basic. It's the length of every side, that's 2.74, times the number of sides, which is 9. Right? And if you do 2.74 times 9, I gotta do it myself. 2.74 times 9, it's 36, 270, 306, plus 18, 21. I think it's 2106. Just want to make sure. I'm waiting for my calculator to boot up. Come on. I didn't have mine ready. Oh, I'm sorry, 24.66. I was a little off there. 24.66. So there's my perimeter. And now I can use that to find my area. Area would be 1/2 the apothem, which is 3.76, times that 24.66 we just got from the perimeter. And we see that my area is 4636. Oops, that didn't write out well. All right. So those are my two. Perimeter up there, 2466. The area is 4636. So you see we use cosine and sine for this one. All right, let's do another one here. All right, we want to find the area of this regular polygon. So we see here that, first of all, 1, 2, 3, 4, 5, 6, 7, 8 sides, right? It's an octagon. Octagon, 8 sides. So right off the bat, if you want to, you say, oh, my perimeter, that's 7 times 8. That's 56. Already got half of what I need. The only thing I need now is I need my apothem. So I'm going to start drawing in my triangle, drop my apothem, drop my radius. And since we know every side is 7, we know half of it is 3.5. And I need my apothem. I don't need the radius in this case because the radius is not part of my calculation. But again, I have one side, I need another, and I don't have anything else. So I do need to find this angle. So again, if you remember, I'm going to take 180 divided by 8, and I get 22.5. So 22.5 degrees. All right, so based on that, guys, you label your sides. You notice the 3.5 is my opposite. My adjacent is my apothem. And it's pretty nice that the apothem is always the adjacent side if you do it this way. And I have my 22.5 degrees. So opposite adjacent, I'm going to use tangent. Tangent, 22.5 equals my opposite, 3.5 over my adjacent A. I need to solve for A. So if you remember, since my A is now in the denominator, it's going to switch whichever's on the left-hand side. So A is equal to 3.5 over the tangent of 22.5. And when we do that, we end up with roughly 8.45. So that's my apothem. So I have my apothem. I already solved for my perimeter. I can now solve for my area. And so my area is 1/2 my apothem, 8.45, times my perimeter of 56. And that's going to give me 236.59. And since we're dealing in meters, meters squared. And there is my area. And I know I'm kind of going fast, but again, we got to remember our trig. All right, this is the last part of this one. Area of an equilateral triangle. So you can still do the 1/2 AP with this. It still works, but equilateral triangles, kind of like squares, they have their own little special formula that can work as well. You can do it with squares too. The 1/2 AP still works with squares as well, but we like S squared. It's a lot easier. This one kind of does the same thing. I'm actually going to prove this to you and then actually do an example. But what you do need to know is that this is the formula. One area of an equilateral triangle is the square root of 3 over 4 times whatever your side is squared. So again, remember, side is just whatever the side length is. So this is S here. The way I'm going to prove it to you guys is I'm actually going to drop an altitude into this. So if you think about it, this is an equilateral triangle, which means all the sides are congruent and all the angles are congruent. So if you think about that, guys, if you know this, then you know that every angle here is 60 degrees. And I'm not going to put a 60 in the top one because I am going to drop my altitude from the top to the midpoint on the other side. Since it's equilateral, it's going to meet at the midpoint. So if you notice that, since it goes right through the middle, this ends up being congruent to each other. That makes each of these 30 degrees. And if you'll notice that this now creates a 30, 60, 90 right triangle with a hypotenuse of S. Now, if you remember your 30, 60, 90s, their ratios are x, x root 3, and 2x. Well, if 2x is S, that means x has to be S over 2, which means that the 60 degree side, or the height in this case, has to be S root 3 over 2, because it's whatever x is. So if you think about it, that's where that comes from. And if you remember, your area of a triangle is 1/2 base times height. Well, then that would mean it's 1/2 the base, which in this case would be, if you talk about it, this whole thing here, that's S. It's S times the height, which is the 60 degree side. That's S root 3 over 2. So you get S root 3 over 2. And if you multiply all that out, guys, S times S, that's S squared, times the square root of 3 over 2 times 2, which is 4. And voila, you see where it comes from. So there's the proof of it, why it works. I'm not going to ask you ever to do that, but I do want you to know where it came from. So you do need to memorize this formula. And here's an example of it. Given a side length of 10, find the area of the equilateral triangle. So using the formula, it's square root of 3 divided by 4 times 10 squared, which is root 3 over 4 times 100. 4 goes into 100 25 times, so 25 times the square root of 3, and we're dealing in meters, so meters squared. All right, guys, homework. Make sure you're practicing, guys. And again, go back over your trig if you do not remember it. And again, thanks for joining us today.